the cosmic cradle birth of a star system. Picture this, a vast cloud of gas and dust floating in the darkness of space. This is where our story begins. Gravity, the cosmic sculptor, starts to work its magic. It pulls the cloud inward, causing it to collapse and spin. As it spins faster, it flattens out like a celestial pizza dough. At the center of this swirling disk, pressure and temperature rise. They climb higher and higher until, boom, nuclear fusion ignites. A star is born. In our case, this star is our sun. But the show's not over yet. Far from it. Around this newborn star, a donut-shaped disk of leftover material continues to swirl. This is the protoplanetary disk. It's made up of gas, dust, and ice particles. These are the ingredients for planetary formation. They're the cosmic building blocks that will give rise to worlds. This disk isn't uniform. It has areas of different temperatures and densities. These differences will play a crucial role in shaping our solar system. They'll determine where different types of planets form. From scorching hot rocky worlds to frigid gas giants, each will find its place. From dust to planetesimals, the building blocks of planets. Now let's zoom in on that swirling disk. It's a busy place. Countless dust particles are zipping around. They're colliding with each other all the time. Most of these collisions end in particles bouncing off each other, but sometimes they stick together. When particles stick, they form larger clumps. These clumps then collide with other particles and clumps. They grow bigger and bigger. It's like a cosmic game of snowball. The bigger they get, the more material they can gather. Eventually, these clumps grow to the size of boulders, then mountains. We call these large objects planetesimals. They're the building blocks of planets. But they're not done growing yet, not by a long shot. Planetesimals continue to collide and merge. Some are destroyed in violent impacts, others grow larger. The largest ones have enough gravity to pull in nearby material. They become like cosmic vacuum cleaners, sweeping up everything in their path. This is how planets begin to take shape. Clearing the path orbital dynamics of planetesimals. As planetesimals grow, they start to influence their surroundings. Their gravity affects nearby objects. They create waves in the gas and dust of the disk. These waves can push or pull other planetesimals. The largest planetesimals clear out paths in the disk. They sweep up material or fling it away. This creates gaps in the disk. We can actually see these gaps in protoplanetary disks around other stars. It's like looking at the birth of alien solar systems. These cleared paths are important. They help stabilize the orbits of growing planets. Without them, planets would constantly be bombarded by material. They might spiral into the star or be ejected from the system. The process isn't always peaceful. Sometimes planetesimals collide violently. These impacts can shatter worlds or create new ones. Our moon likely formed from such an impact. A Mars-sized object hit the young Earth and the debris coalesced into the moon. Ice giants and gas behemoths, formation in the outer reaches. Let's journey to the outer regions of our forming solar system. It's colder out here. So cold that gases like hydrogen and helium can freeze. This creates a playground for a different kind of planet formation. In these frigid realms, dust particles are coated with ice. They stick together more easily. They form large icy cores. These cores grow massive enough to start pulling in gas from the surrounding disk. And boy, do they pull in a lot of gas. The result? Gas giants like Jupiter and Saturn. These behemoths are mostly hydrogen and helium, but they have rocky, icy cores at their centers. These cores are remnants of those original icy planetesimals. Further out, where it's even colder, we get a different breed of giant. Ice giants like Uranus and Neptune. They have a higher proportion of ices, water, ammonia, and methane. They're like cosmic slushies, with a dash of rock and gas thrown in. Section 5, Rocky Worlds, the inner solar system takes shape. Now, let's head back to the warmer inner regions. Here, it's too hot for those ices to form. Only rocky materials and metals can survive. This leads to the formation of smaller, denser planets. These rocky planetesimals smash together. They melt from the heat of impacts and their own radioactive elements. As they cool, they differentiate. Heavy elements sink to the core. Lighter ones rise to the surface. The result? Terrestrial planets like Mercury, Venus, Earth, and Mars. They're small compared to the gas giants, but they're dense. They have metallic cores, rocky mantles, and thin atmospheres, if any. Earth, of course, is special. It's just the right size and distance from the sun to hold on to water and support life. But each of these rocky worlds has its own unique characteristics. We'll explore those soon. Section 6. Our Cosmic Neighborhood, an overview of the solar system. Let's take a step back and look at the big picture. Our solar system, born from that swirling disk of gas and dust, is now a diverse family of worlds. 8 planets orbit our sun, each with its own personality. Starting from the sun, we have Mercury, Venus, Earth, and Mars. These are the rocky terrestrial planets. Then comes the asteroid belt, a region of leftover planetesimals. Beyond that are the gas giants, Jupiter and Saturn. Finally, we reach the ice giants Uranus and Neptune. But planets aren't the whole story. We have dwarf planets like Pluto, moons some as large as planets themselves, asteroids, comets, and countless smaller objects. Each plays a role in the complex dance of our solar system. This arrangement isn't random. It reflects the conditions in the early solar system. The inner region was too hot for gases to condense, leading to small rocky worlds. The outer region was cold enough for ices and gases to form giant planets. Section 7. Mercury and Venus, the Sun's closest companions. Let's start our planetary tour with Mercury. It's a tiny world, not much bigger than our moon, but don't let its size fool you. Mercury is dense, with a large iron core. Its surface is heavily cratered, like a battered punching bag. Mercury's days are scorching hot, its nights freezing cold. It has no real atmosphere to speak of. The sun looms large in its sky, over 3 times bigger than it appears from Earth. Mercury's a world of extremes forged in the fires of our star. Next up is Venus, often called Earth's evil twin. It's similar in size to our home world, but that's where the similarities end. Venus is shrouded in thick clouds of sulfuric acid. Its surface is hot enough to melt lead. Venus rotates backwards compared to most planets. Its day is longer than its year. It's a testament to how differently planets can evolve. Venus might have once been more Earth-like, but a runaway greenhouse effect turned it into the inferno we see today. Section 8. Earth and Mars, the Terrestrial Twins. Ah, Earth, our blue marble, our home. It's the only world we know that harbors life. Earth is a water world with vast oceans covering most of its surface. Then we have Mars, the red planet. It's smaller than Earth, but it's captured our imagination for centuries. Mars has polar ice caps and seasons. Mars once had liquid water on its surface. The possibility of past or even present microbial life makes it a prime target for exploration. Section 9. Jupiter and Saturn, the gas giant duo. Now we enter the realm of the giants. Jupiter is the king of planets. It's more massive than all the other planets combined. Jupiter is a swirling ball of hydrogen and helium, with no solid surface to speak of. Jupiter's most famous feature is its Great Red Spot. This storm has been raging for centuries. Jupiter also has a faint ring system and dozens of moons. Some of these moons, like Europa, might harbor subsurface oceans. They're worlds in their own right. Saturn, the jewel of the solar system, comes next. It's known for its spectacular ring system. These rings are made up of countless ice particles, ranging from dust-sized to boulder-sized. They're so thin that if you turn them on edge, they'd nearly disappear. Like Jupiter, Saturn is a gas giant with no solid surface. It has a diverse family of moons. Titan, its largest moon, is the only moon in the solar system with a thick atmosphere. Enceladus shoots geysers of water into space from a subsurface ocean. Saturn is a miniature solar system in itself. Section 10. Uranus and Neptune, the ice giants on the fringe. Out in the cold depths of the outer solar system, we find Uranus and Neptune. These are the ice giants. They're smaller than Jupiter and Saturn, but still much larger than Earth. They're composed mainly of ices, water, ammonia, and methane. Uranus is tilted on its side, probably due to a massive collision in its past. This gives it extreme seasons. For part of its year, one pole faces the sun continuously, while the other is in darkness. Uranus has a faint ring system and a family of moons named after Shakespearean characters. Neptune, the last of the planets, is a striking blue. This color comes from methane in its atmosphere. Neptune is known for its wild weather. It has the fastest winds in the solar system, with speeds up to 1,500 miles per hour. That's faster than the speed of sound. Both Uranus and Neptune have been visited only once by spacecraft. Voyager 2 flew by them in the 1980s. There's still so much to learn about these distant worlds. They're a reminder of how much we have yet to explore in our own cosmic backyard. Section 11. Journey's End. An invitation to cosmic exploration. We've traveled from the birth of our solar system to its farthest reaches. We've seen how specks of dust can grow into majestic worlds. We've explored the diversity of planets, from scorching Mercury to frigid Neptune. But our journey doesn't end here. It's just beginning. Every day, we're learning more about our solar system. Robotic explorers are roving on Mars. Spacecraft are orbiting Jupiter and Saturn. We're planning missions to the moons of the outer planets. And we're not just looking at our own system. We're discovering planets around other stars. These exoplanets are revealing that planetary formation is even more diverse than we imagined. We've found hot Jupiters orbiting close to their stars. We've detected Earth-sized worlds in the habitable zones of other suns. The universe is full of possibilities. So I invite you to keep exploring. Look up at the night sky. Those points of light have stories to tell. They're worlds waiting to be discovered. The cosmos is vast and full of wonders. And you, dear reader, are part of this cosmic story. You're made of star stuff, forged in the hearts of ancient suns. The journey through the cosmos is your journey too. Keep asking questions. Keep wondering. The adventure never ends.